Yeah, so my name is Chance. I'm from the Ethereum Foundation Privacy and Scaling team, and I'm here today to talk to you about Unirep, which is short for Universal Reputation. So Unirep is an anonymous reputation system that can be overlaid onto sets of anonymous users. And in this system, users can prove, spend, and receive reputation. And interactions are facilitated by an attester. And this attester can be an immutable contract, an externally owned account, or some combination of the two. So you can think of an attester like an ERC20 contract. A token contract has no meaning or value intrinsically. The meaning is defined by who's operating it, the logic implemented within, and sort of the ecosystem around it. And attesters are the same. They're defined by the logic implemented in them or implemented off-chain and the ecosystem surrounding it. So yeah, we tend to think of reputation as a signal of what members of a set think of a specific member in the set. It's just an additional signal from an anonymous member of a set. So I'm going to give a quick and incomplete technical overview of how it works. So we users sign up with a semaphore identity. And this identity is composed of two private components, the nullifier and the trapdoor. And from that, we compose the secret, which is the hash of the two. And then we identify users in Unirep using epoch keys. And these keys are the hash of the secret, the current epoch number, and the snods value. So an epoch is a parameter set at the protocol level, and we usually set this at about 1 day. So as you can see, the preimage of this hash changes every epoch, so the user's key changes every epoch as well. This nonce is another parameter we set at the protocol level. We usually set this to 3, and this basically allows us to give a user multiple keys in a single epoch, so they don't have to identify themselves if they post multiple times or use a single key multiple times. So because we use this relatively simple hashing system, we can prove kind of a lot of things. We can prove ownership of an epoch key, ownership of 2 different epoch keys in different epochs, and non-ownership of an epoch key. So how do we store all this stuff? We have a global state tree that's an incremental Merkle tree for every epoch. And each leaf of this global state tree is the root of what we call a user state tree. And each leaf of the user state tree is a hash of the reputation given by a certain attester. So there are many attesters. We hash the reputation given by a single attester along with the identity commitment. And that's the leaf in a user state tree. And then we put that into the global state tree. And then whenever a user wants to prove how much reputation they have, they submit 2 Merkle proofs into a ZK proof, and they're able to prove membership of this positive reputation or negative reputation inside the current global state tree. And so as you can see, reputation is composed of positive reputation, negative reputation, and graffiti. And graffiti is just the hash of some arbitrary data that is free for attesters to use as they like. Yeah. So what we've built on top of this is a prototype application called Unirep Social. And at its core, it's a smart contract attester operated by an externally owned account. And in this system, we're able to spend reputation to make comments and posts. And then users are able to spend reputation to vote on these comments and posts, and thus give or take away reputation from the author of the posts. We also use this graffiti value that I just talked about to register a persistent username. So the user can optionally prove the preimage of their graffiti to show this username on a post, so they can optionally identify themselves across epochs as some username. And we implement that logic inside of the Unirep Social smart contract. So it's just like, is this username free? Is it taken? Otherwise, if it's free, then we attest to them having that username, and then they have the username. Yeah, and we also allow users to spend reputation using reputation nullifiers. So Unirep, the protocol, isn't necessarily opinionated about how users spend reputation. It's just an attestation system. But we do have this sort of built-in system that allows you to spend reputation using nullifiers. And that's what we use in this. So that's the last slide. There's a demo video as well. Are you guys going to play that? Just go next. OK. Cool.
This is the homepage of Unirep Social from the perspective of a user that is logged in. You'll see that it looks like a normal social networking site. There are posts, and the posts have comments, and the posts themselves can be voted on, and the comments can be voted on as well. One thing you'll notice that's different is there are no usernames. Instead, you have the epoch key hashes that are shown as having authored the post. You'll also notice that some of these authors have lightning bolts next to their name. When we create a post, we create a reputation proof, and in this reputation proof, we can prove that we have some amount of reputation. So in this case, the person proved that they have 22 reputation. So we know they have at least that much, but we don't actually know how much they have beyond that. So let's go through the flow of creating a post. Immediately see that there are two input fields, one for a title and one for the content. This content is collectively hashed and then broadcast on the blockchain, and we store the actual content off-chain and serve it to the front end. So let's create a post. Then if you look at the bottom, you'll see that you have your identities that you can post from, nonces 0, 1, and 2. As we talked about before, these are separate hashes and they cannot be associated with each other except for by the user that created it. We also have this third field called subsidy, which is some custom logic that we built into Unirep Social for actually creating reputation. This is how reputation is created within the system instead of doing an airdrop. So we'll select this middle epoch key, and then we'll choose to show that we have at least 10 reputation, and we'll spend 5 reputation to make this post. As you can see at the bottom, a ZK proof was generated, and it's been uploaded to the backend, which is now broadcasting a transaction. And there you have it. That's a post on Unirep Social.
Yeah, so as you can see, it generated a ZK proof to do that operation. It generates ZK proofs for all these operations in the browser. Yeah, that's it. You can see this stuff at github.com/Unirep.